Okay, Mr. Carmen said, scientists discovered the world that already exists, engineers create the world that never was. Good afternoon, my name is Shahid Amin, and my project was to design single-chamber artificial heart. Today I'm first describe the outline of my presentation. I'm going to introduction first, then I'm going aims of the project, then what methodology I use to my project, design goals, what the design goals, the setup, initial design idea, from initial design idea to this idea, how I came through, CAD design, and what load test I performed on my single chamber artificial heart. I'm going to explain you how the operation will work, electrical circuit block diagram, conclusion of this project, and the MATLAB programming, and the future works, what will need to be done in the future. What do you guys think? Engineering and medical, they are both different fields. And what do you think? What's the relationship between two fields? The engineers need to create such instruments and equipment which allows medical professionals to diagnose diseases and understand them easily. For instance, if the machine is measuring in a blood how many red cells we got, if the machine is not giving us the accurate measurement, the medical professionals giving the prescription based on the machine's output or the machine's result. So the engineers are very important in terms of making machines and their links to medical professionals to make the machines very accurate, which allows medical professionals in the future to diagnose diseases very effectively. What do you guys think the number one cause of death in the present age? Well, you are wrong. According to the World Health Organization, cardiovascular diseases are the number one cause of death. In 2011 alone, more than 11 million people died due to the heart diseases. That is 3 out of every 10 people died in just alone in 2011. So how human heart works? Let's have a look at this picture. The blue line is the blood going from the body, going to the heart, going to the lungs, and going back to the body. So what's the main function of the human heart? The blood in our body circulates in our body, and it becomes carbon dioxide and also diluted with the other toxic substances. The heart right atrium gets blood from the body, from a right ventricular, it's pumping back to the lungs, and the lungs where the heart gets all carbon dioxide ejected and the oxygen injected to the blood, and also nutrients injected to the blood to move into the human body. As might be some of you know, if we run faster, our heart speed faster and faster. The reason behind is our body needs more fresh blood. So that's why the main reason for heart diseases are because the people got no healthy eating, less exercise, and that's the main cause. So that's why the medical professional give you to do exercise, because when you're doing exercise, your heart or the circulation of your blood move faster, and the more oxygenated blood go through in your body, make you more active and healthy. The aim of this project was to design a single chamber artificial heart powered by a pneumatic cylinder using compressed air. The main objective was to the output characteristic of this artificial heart will be the similar of ECG waveform, electrocardiogram wave. The methodology was used because this project was not just in one direction project. This project was based on mechanical, pneumatics, electrical, and computer-based software design. So by starting project, first thing was to calculation of the O-ring, groove size, the piston diameter, and the bore size of the heart. Once the calculation was agreed, then the model was designed using SolidWorks software. After designing SolidWorks software, ordering the material, like this material is made from a machine-graded polycarbonate. To selecting this material is because it's clear characteristic, and we can see what actions are going on, how the blood is pumping. And once the part received, drawing is given to the university technician. They fabricated this part, and after receiving fabricated part, test stage came where the test was done on this artificial heart to see how much fraction the compression due to the O-rings was involved, how much force we need to operate this one. If the force we are looking for, we agree, we need to move to the ordering pneumatic circuit. If the test was failed, what we're looking for, we need to redesign and modification over drawing, and then testing again, and then assembly part, electrical design, then MATLAB design, MATLAB writing MATLAB program, and same situation in each stage, testing and reversing back if it's pass or fail, what we're looking for in our project, and then we're going to finish our project. So the design goal was to get the O-ring from ISO 3601. It's a standard, international standard for matrix O-ring. So the O-rings will be available in the market easy access. The second thing was the artificial heart bore design calculation based on the O-ring, designing model using SolidWorks, calculating pneumatic cylinder based on how much force we need. So which type, the pneumatic cylinder we need, the diameter of pneumatic cylinder, how much force we need to generate to operate this artificial heart. And then selecting pneumatic cylinder parts like non-directional valves, directional control valves, and push fittings and stuff like that, and electrical circuit design, and writing MATLAB codes. Well, the initial design, as you can see, that's the initial design was set up, and the heart using two, as you can see, it's 2 nanoreturn valves. The basic idea on using 2 nanoreturn valves is the blood flow into the one direction. So when it sucks in a pushing stage, the saline water, which is the blood, is just pushing back, and this one non-return valve block the flow on this direction. So when it's pushing, the blood flow on one direction, it's not going reversing back. So that's CAD design. This model, as you can see, is fully assembled now. But in real term, that's drawing. The technician after drawing gave me this part. So it was pretty good in that sense. The technicians have done very good job designing the piston block for artificial heart, and the piston was also drawn on SolidWorks, and the fabricated parts done by technicians in a university laboratory. As you can see, this is the base plate model, and that's grooves been set up to allow us to move if we want to increase the blood fluid output. So we can move our cylinder, and it will give us a bit flexibility to increase the volume in our artificial heart. Right. To see how effective our heart is, how it's the operating characteristics, different test was performed by Lord. So how we came across how much force need to be operating and how much compression ratio cause the movement of artificial heart. So the first test was it's just how much operating force required. The test was performed at the O-ring compression 10%, and the results came up 1100 grams. So 1100, putting 1100 grams weight, it's moved. So the force required 1100 grams to moving. The next stage was to checking if that's the 10% is give me the inner ceiling, will it leak? So what I did, I've applied, as you can see, the pile of 35 kg load on this cylinder and no water leaking. This bit is a bit water leak because it's from this PTF fitting was not properly fitted. So, but O-rings still got the compression. As you can see, this is the water level in middle, and it's providing very solid sealing characteristics O-ring. Right, the next stage might be some of you know how directional control valve work and how solid coils work. This one is a 5 port, 2 direction solenoid valve, directional control valve. This, if in your real life, if you came across a directional control valve, when you see it, so you can, by looking at it, you can know which is your pressure port, which is your which is your pressurized port, and which is your exhaust port. So that's, in this case, solenoid coil is not energized, and the pressure is going from port P and going port B over there. As you can see, top picture, the pressure is putting on point B side, it's moving back. So the similar, but by applying, now it's a solenoid coil is energized and the cylinder is moving forward stroke. As you might know, it's holiday season, and the part is still in delay and need to be ordering. So the test was done by manual applying the air, and as you can see, it's pretty much in smooth operation of the artificial heart. So that was done in a laboratory, and as you can might see, even though it's here, the ears it becomes a bit sticky. See? So it's pretty good in terms of the operation. It need less forces. So that's the electrical circuit. The lab jack, because the lab jack is powered by USB and it's got 330 milliamps maximum current output at 5 volts. So the current limited resistor used, switching the transistor, and the transistor switching the relay. So the relay is operating another relay to power the solenoid valve, which one is here, and external 24 power supply used. So in a real term, if you see the MATLAB program written, interference with the lab jack, and lab jack is connected to this electrical circuit board and 2 reed switches. That's the reed switch 1 and 2 is connected. So the reed switch is going here, as I'm still waiting for a part, to move it up and down, and they will tell which position the cylinder is. And then based on that, it's going back to lab jack, to the MATLAB, and they make a decision which direction we need to move. This conclusion, this project is a part of non-invasive electromagnetic flow monitoring for image arteries blood flow in artificial limbs. So the School of Engineering is doing the project to measure the blood flow characteristics in the limbs, which will affect in the future diagnosing heart diseases, and in limbs what the cause of these heart diseases can affect. So the future work requires, once the parts will be received, you need to connecting together, wire up, and writing MATLAB program. Thank you for listening. Any questions?
Very good. Well, I know this project very well, so I haven't got too many questions. Could you email me your talk, please? Because there are a few things like the video that I have to see before after the meeting. Anybody got any questions? I have to say, I know this project so well, you know. Has anybody got any other questions? Well, I think that was a very good presentation, you know, very good actually. It was very lively and kept lots of time. It's nice showing the movie in there as well. So I'm very well done. Thanks.
Okay, thank you.
Oh, yeah, okay. Very good.
Very good presentation. Now I know you are really professional. Now I know. No, you told me I don't believe you, but now I believe you. Very good. Very good.
All right, thank you.